In this video, we will be briefly looking at the Nortel 350 telephone. This is a telephone that was manufactured by Nortel in the late 90s, and they later, I think they stopped making them, but another company was manufacturing them for a while as well. And this is the model that was used for the US West home receptionist phone. And there were several different brandings. Some of these say Nortel on them. Some of them said US West. This one has the Bell Canada logo because this phone actually came from Canada because of how hard it is to acquire phones like this nowadays. This is an extremely, or at least a relatively rare and unique telephone, in that it is one of the only telephones, to my knowledge, that has ADSI capabilities. ADSI being Analog Display Services Interface, which most people have never heard of and never will. But if you know what it is, it's actually a very cool technology, and it's one of the neatest things that you can do with analog telephony. Most people think, oh, you can't do XYZ with analog phones, and often there are cool things that you can do, like ADSI, with analog phones. So this is essentially one of the most advanced analog telephones that has ever existed. I mean, put the fourth column DTMF and some other stuff on here, you'd have a super phone right here. So I've just hooked this up today, and I really haven't done a lot with it. It's plugged in, so it's a single line phone, and you can plug another phone into it. So I've plugged this phone in just because they didn't have a lot of extra ETA ports, or any extra ETA ports. And it also has power cord. The phone itself works without power, but the screen obviously requires power. So that's why it's plugged in. Now, phones that support ADSI are pretty distinguishable by the characteristic two columns of 3 buttons on the sides of the screen. And if we zoom in to about there, that is pretty much how most phones that support ADSI, that's kind of what they look like. They've got the 3 buttons like that and the 3 buttons like that over there. So the 350 is the most common model that supports ADSI. I think there is also the 390 and the 480, or I'm getting the numbers mixed up probably. There were a couple other. If you look up ADSI on Wikipedia, you can read about them. But anyways, as far as this phone is concerned, so fairly normal stuff. Over here, hold. Link is actually your flash button. Link is a term used in, I would say, places that aren't the United States. So this could have just been the phrasing used on the Canadian manufactured phones, or the ones that were manufactured for Bell Canada. Goodbye is just a hang up button. Options just gets you some options here, and fairly standard stuff in here. I don't know why you would want to configure the time and date, because that's set when you get an incoming call if you have caller ID. Ringtone, call timer, nothing super outrageous or special in there. Standard 12 button keypad, volume control, and then some special service buttons over here, which I haven't messed with really a lot, but I think the directory might even be programmable, I'm not sure. Possibly through ADSI, but you got your recent calls here, services. This I'm pretty sure can be programmed, and then copy, print, and your redial. So it shows my last number dialed, which I always use last number redial or pound for last number redial. But I guess if you dial the number, then you could use that too if you didn't have that service. So and I actually don't remember what the... Is that this phone over here? Oh no, that's this phone over here that I called. Okay. Yeah, so maybe that's the reason not to use last number redial with ##. That way you actually know what you last called. Anyways, so that's what most ADSI phones look like. So I haven't played around with a lot. Certainly I don't have anything ADSI-wise working yet. But for a brief demonstration, it's interesting the way that these two react to Type 2 caller ID, or call waiting caller ID. So if we use this phone here, I'm just going to call a number, and so that's doing that. And if I go ahead and I give myself a call waiting, okay, so you see there's the call waiting caller ID, and that's the station that called. And I have the console up. You'll see that I have DTMF debug turned on, and those are the digits that I just dialed on the other phone here. What you don't see here is you don't see a DTMF, which is what the CPE would actually send. This is a weird edge case where I found that Cisco ATAs seem to somehow squelch that DTMF or suppress it somehow, so it never actually gets sent. But this phone is generating that DTMF. If you clip on with the butt set, you can hear that. So I have some code in there that will figure out if we've got an endpoint that probably does support this, and in that case we just spill the FSK anyway. So that's what this is. This is on a Grandstream ET over here. So this doesn't have that issue. It's only Cisco products that have that issue. So if I do the same type of test over here, okay, so we've got some of that, and let me just get rid of that there. And if I go ahead and I use this phone to give myself a call waiting over here, okay, so that was call waiting that came in, and now if we look at the DTMF debug over here, you'll see that there's a number I called over here as I was calling the number 2122, and then you see that I got an A on this channel. DTMF received A, which you can probably see, and the reason nothing else is happening is because I don't have any code currently set up to, and of course that's my call waiting coming in. I don't currently have the code set up to handle ADSI, but what you might have noticed there is that at least certainly nothing displayed on the screen. So this is CPE, or customer premises equipment, that does react to the CPE alerting signal, which is how Type 2 caller ID works. And it sent an ADTMF, but clearly this phone is not expecting the FSK spill that it got. You know, that's what made it display the call waiting caller ID here, but that didn't happen here. So apparently it is expecting something else, probably an ADSI script, so that you get your call waiting deluxe options here, the 5 or 6, I forget, the 5 or 6 call waiting deluxe options here if you have that service, or at least an ADSI script that maybe has the name of whatever happened. So that is programming that has yet to be done, but that is a look at the difference between sending the A and the D with with the response to the CPE alerting signal, which I should have mentioned briefly, but basically the way that it works is, first you might hear the subscriber alerting signal, or the call waiting tone, basically, in layman's terms, and then you hear that little high-pitched squeak, which is the CPE alerting signal, or the CAS, and that's what CPE, or, that's what phones with screens are actually listening for. Caller ID units, that's what they care about. They don't care about the call waiting tone. That's for you. The CAS is what's for a machine. That's what it's going to listen for. And when it gets that, it's going to send either an ADTMF or a DDTMF. And if the switch gets one of those, that's how it knows that they're supporting equipment that can display or make use of that. And if it doesn't get one of those back, it's not going to send anything, which is why if you have just a normal phone plugged into a line with no screen, you're not going to hear an FSK spill because it's not sent. So this phone is sending a D because it doesn't support ADSI. This phone is sending an A because it does support ADSI. So that's the difference there. And because this is sending an A instead of a D, my switch has to handle that differently. So that is the next phase of programming that will need to be completed.